We've all been there, right?
Yeah.
That quiet frustration, just watching something crawl, wishing things would just click and move faster. Whether you're, I don't know, waiting for a file to upload or just hitting a project deadline. Getting things done quickly, effectively. It's a universal challenge.
It really is. It's that basic drive for efficiency, isn't it? Trying to get rid of the friction.
Exactly.
Yeah.
And today, we're taking a deep dive into precisely that, but in a really specific and I think quite fascinating context.
Oh.
Pharmaceutical manufacturing.
Yeah.
Specifically, tablet production.
Ah, okay. Yeah, and our sources today give us this great real-world case study. It's about a pharmaceutical company making film-coated tablets. And they were grappling with some pretty significant operational hurdles. It was leading directly to customer complaints because deliveries were late.
Right. And what's interesting is how fast they seem to zero in on the core problem.
Yeah.
Like, a preliminary analysis showed their total batch cycle time for these tablets was, well, it was a staggering 72 hours.
72 hours.
Think about that. 3 full days just to get one batch out the door.
It's a perfect example of how, sometimes just that initial look can pinpoint a massive issue. Their analysis pointed to 2 main culprits. 2 stages causing frequent costly delays.
Which were?
Tablet compression and coating. And this wasn't just a minor slowdown, it actually caused a huge amount of work in process WIP to pile up right before that bottleneck equipment.
Okay, so like a traffic jam on the factory floor.
Exactly. But it's more than that. It's capital tied up, raw materials sitting idle, space being used up, all before it even gets close to the customer. A really costly symptom.
It's amazing how just a couple of friction points can almost paralyze a whole system. Makes you wonder, are we always finding the root cause of delays or just, patching symptoms?
That's the key question.
So, okay, to really get our heads around this 72-hour monster, let's walk through the main steps. Where was all that time actually going?
Right, yeah. Understanding the individual time sinks is crucial. So first up was granulation, wet granulation specifically. That took 14 hours.
14 hours for granulation. Why so long?
The main reason noted was an unusually high drying time. That really stretched it out.
Okay. Then after granulation.
Then came milling and sieving. That clocked in at 4 hours. And the source mentioned this was largely down to manual handling.
Ah, so maybe an opportunity for improvement there, too, even if it wasn't the main bottleneck.
Potentially, yes. Then came blending, which took 6 hours. The critical factor here was often just waiting for the blender to be free.
Okay, waiting time. Got it.
But here's where the real bottlenecks show up. The next 2 steps. That's where the biggest time sinks were. And, the biggest opportunities.
Right. These are the ones that really jump out. Compression, the first big one, a massive 18 hours.
18 hours, yeah. The problems, frequent stoppages and constant changeover issues. Basically, the machine was down almost as much as it was running.
Wow. Okay, and then the longest step of all.
Coating. That ate up a whopping 24 hours.
24.
Yeah. Also, a clear bottleneck. They were struggling with a really low spray rate, so the coating wasn't going on efficiently, and very frequent, very long cleaning cycles.
Okay, so inefficient coating, long cleaning times adds up.
Definitely. And finally, there was packing, which took 6 hours. But the analysis rightly pointed out that this step had kind of limited impact on the total 72 hours.
Because the damage was already done upstream.
Exactly. The major delays were happening long before the product even got to packing. So you added up 14 for granulation, 4 for milling, 6 for blending, 18 for compression, 24 for coating, 6 for packing.
And there's your 72 hours.
There it is, the full 3 days.
So facing 18 hours at compression and 24 at coating. This wasn't just about minor tweaks, was it? This needed a proper strategic overhaul.
Absolutely. Their mission became really clear. Systematically take apart these choke points, turn those customer complaints into, well, a roadmap for getting radically more efficient and fixing those delivery problems.
Okay, so we've got this picture. A company bogged down by this massive 72-hour cycle, unhappy customers, pressure on the bottom line. The big question is, how did they actually turn it around? How did they make it efficient?
Right, and that's where their focused approach really paid off. They didn't just, guess or throw random solutions at it. They pinpointed the pain points and brought in specific targeted initiatives.
Like what? For compression, for instance.
Okay, for compression, where those changeovers were killer, they implemented SME,
SMED.
single-minute exchange of die. And they brought in quick cleaning changeover kits. Now, SMED isn't literally about 1 minute.
Right, it's a methodology.
Exactly. It's a systematic way to slash the time it takes to switch a machine from product A to product B. A lot of it is about moving tasks you used to do while the machine was stopped to doing them while it's still running the previous batch.
Smart. Making setup happen in parallel.
Yeah.
And the impact.
Huge. It cut the average changeover time from 2.5 hours down to just 1 hour.
Wow, saving an hour and a half every single time they changed over.
Precisely. Think about how many changeovers they do in a year. That adds up incredibly fast.
No kidding. Okay, what about coating? The 24-hour beast with the slow spray and long cleaning.
Right. So there they upgraded the spray nozzles. That let them apply the coating faster and more evenly. And crucially, they introduced automatic cleaning. That got rid of the huge downtime and, frankly, the variability that comes with manual washing.
Taking the human inconsistency out of it and the time.
Exactly. And that slashed the average cleaning time from 4 hours down to 2 hours, saving a solid 2 hours every cleaning cycle.
Another big chunk of time saved.
Definitely. And it wasn't just about fixing individual machines, though that was vital. They also made a really smart tactical move.
What was that?
They optimized the schedule for both compression and coating. They started grouping similar batches together to run back to back.
So fewer changeovers overall.
Exactly. Reduce the number of times you have to do those time-consuming changeovers in the first place. It maximizes the uptime of those machines, which are now faster anyway.
Makes perfect sense.
Yeah.
Anything else?
Yeah, one more thing for blending. They actually added another blender to ease that waiting time bottleneck, and they optimized some of the manual material handling around it. That cut the blending step from 6 hours down to 4, another 2 hours saved.
Okay, so improvements across the board.
Yeah.
But really targeted at those key bottlenecks and surrounding processes.
Right. And the cumulative effect is where you see the real power, which brings up the question, okay, what was the actual measurable impact?
Yeah, the bottom line. Let's talk numbers.
When you crunch the numbers, based on their typical 200 batches per year, the total annual time saved across all these processes was an impressive 1,400 hours.
1,400 hours a year.
Wow. And in financial terms, does the source quantify that?
It does. They estimated an average machine cost of about 4,000 rupees per hour. So 1,400 hours times 4,000. That translates to a massive cost saving of 56 lakh rupees.
56 lakhs.
Yeah.
Every single year.
56 lakhs. I mean, that's the kind of money that can fund whole new projects, R&D, boost profits.
Yeah.
It's significant. Absolutely huge. But it wasn't just cost savings, right? There were other benefits.
Oh, yeah, absolutely. Beyond the direct financial gain, which was obviously immense, the company saw several other really important improvements.
Like?
Well, remember, the customer complaints about late deliveries. Their on-time delivery rate improved drastically. It went from around 80% up to 95%.
Huge jump. That must have done wonders for customer satisfaction and just their reputation.
You'd have to think so, yeah. Especially in pharma, where reliability is just critical.
True. What else?
They also slashed their work-in-process inventory, that WIP we talked about. They reduced it by 30 lakh rupees.
So 30 lakhs of capital freed up, basically.
Yeah.
Less money tied up in stuff sitting on the factory floor.
Exactly. Better cash flow, lower holding costs, and on top of all that, they actually increased their batch throughput capacity by 8%.
So they weren't just faster. They could actually make more product in the same time frame.
Correct. More efficient and higher capacity. It's a win-win.
Okay, so this is a fantastic case study from pharma manufacturing. But what does it all mean for you listening right now?
Yeah, that's the key takeaway, isn't it? Because this deep dive offers a really powerful lesson that honestly goes way beyond just making tablets. The principles here: identifying your real bottlenecks, doing that forensic analysis of efficiency, putting in targeted, systematic solutions that can apply to almost any process in your work, even in your life.
Yeah, it's really about more than just going faster. It's about breaking down those big, maybe overwhelming problems into parts you can actually manage and solve. It's about challenging that status quo, thinking of, oh, well, this just takes this long. So as you go about your own routines, maybe your project workflows at work, or even just personal tasks, it's worth considering, where might your 72-hour cycle be hiding?
That's the provocative thought, isn't it? What small, maybe seemingly insignificant delays or inefficiencies are lurking in your world? If you tackled them strategically, with the kind of focused approach we saw here, what could that unlock for you?
Speed like significant time, resources,
Yeah.
maybe even just some peace of mind.
Exactly. Something to think about.